So we're now going to look at another polar equation, and this has to do with circles. So the next polar equation we're going to work with is r equals cosine theta. So what we're going to want to see is the graph in terms of writing it out as theta along the horizontal axis, r along the vertical axis, and we're going to want all of these points because where we have to graph this polar equation of r equals cosine theta is on a polar plane. So in order to graph on a polar plane, you need r and theta. So we're going to grab a bunch of r's and thetas here. This is just the same right here, should look the same as the graph of y equals cosine x. So I'm going to go ahead, that's just the parent cosine x. I'm going to go ahead and fill in this table of values and make the graph. So I've got my polar coordinate plane there. If you notice, I kind of made one myself that's a little bit bigger because in terms of bigger, I mean I made the circles a little bit bigger because if you look at your r's, okay, you can see from this graph cosine of theta, the largest radius that you will get when you do cosine of theta is 1. The smallest r you could get is -1. So you know that you're not going to go larger than an r of 1. So if we now take this data that we have here and we plot it on the polar coordinate plane, that's what we're going to want to do, and we're going to see what we get. So when r is 1, theta is 0, so no rotation, r is 1. Okay, and when theta is 30 degrees, r is 0.86, 45.7. I'm going to graph all the points up to 90 right now. Now, it might look a little funky just because I did this by hand, but this appears to be, if I connected that, that is half of a circle. So if I do one, the next one is r is -1/2 and theta is 120 degrees. So if I rewrite that, okay, r is -0.5, theta is 120. I want to graph that, so I want a positive r. So this is going to become 0.5, 120 plus 180 puts us at 300 degrees. So 0.5 r, 300 degrees, that's going to put us right there. And, oh, I think I see why it might not be such a semicircle is because that point needs to be more here. 0.5. Okay, notice these are the same distance away. Next, -0.71, 135. That would become 0.71, and then 135 plus 180 is going to put us at 315. So 315 is going to be 0.71. And then 150, and r is -0.86. That's going to become 0.86. And then 150 plus 180 is going to put us at 330. So 330, 0.86. And then 180 and -1. R is -1. Theta is 180 degrees. If you make this positive, add 180, puts you right back. And then if you continue, 210 theta, -0.86. If you write that with a positive r, if you add 180 to 210, you are going to be at 390. So this point right here would be 200, okay, the point of -0.86, sorry, 210 degrees. Can't really see that. Let me redo that. -0.86, 210 degrees would become 0.86, 390 degrees. 390 degrees is coterminal with 30 degrees. Notice it's got the same r value. So it would just sit right on top of these points. So these points would just continue making this shape. This is a circle. So what this is showing is, what is R when you take cosine of the angle that you're at? So we can see that the circle, we've got a circle there, and it's got a diameter of 1, and it is going to, I'm going to actually show this on Desmos for a second so that it's a little clearer. So if you take a look at it on Desmos, you could see R equals cosine theta. We've got this nice circle. Notice it's tangent to the line. X equals 0. Okay. It hits 0, 0 and opens to the right. The circle, it goes to 1, 0. So let's see what would happen if we made it R equals 2 cosine theta. So here's R equals cosine theta. So now I'm going to click and I'm going to show you in blue is going to come R equals 2 cosine theta. So notice it's still opening to the right and it now has a diameter of 2. Now, what would you think would happen if we made this A value, that's the coefficient in front of cosine, if we made that negative? What do you think would happen? So to figure out what it's going to be, instead of just writing it in, why don't we do the same thing we just did for R equals cosine of theta? Why don't we sketch this in terms of this kind of graph, and then what we'll do is we'll make a big table of values, and then we'll plot it. So that's what we should do right now. Make it, use the same inputs, get the new outputs when it's negative cosine theta, which is a quick little manipulation of what we already have here, because it just means we're taking all of these R values and we're multiplying them by -1. So this will be a quick table of values you should be able to make, as well as this graph for R equals negative cosine theta. So here's our table of values. So now we're going to sketch this polar curve on the polar coordinate plane. We're going to see what we get. So what the polar coordinate is, R represents how far we're going to go out from the center, and theta represents the amount of rotation. So this picture picks that up. When I pick up this point, I'm finding that R is 1. So at 180 degrees, R is 1. So I know I'm going to go out 1 when I'm at 180 degrees. So let's see. The first point is 0. R is -1 and theta is 0. So that would be 1, 180 degrees. So 1, 180 degrees is going to be over here. So now we go through and I'll plot all the way up to 90 degrees. So what I get, if I connect these, I've got half of a circle up to the 90 degrees. I've got half of a circle, but instead of on the right side of the the y-axis, I'm on the left side. If I continue, if I plot all of these points, I am just going to have a circle. Okay, so I'm going to show you on Desmos that circle. So that is the circle you would get if R equals negative cosine theta. So here's all 3 of them. I'm going to put up now R equals cosine of theta. Circle opens to the right. R equals 2 cosine theta opens to the right. So let's generalize for all R equals A cosine theta. So when we have R equals A cosine theta, we're going to be a circle. And if A is greater than 0, you're going to have a circle that opens to the right and is tangent to the line x equals 0, the vertical line x equals 0. Now, the diameter will be A. If A is less than 0, you're going to have a circle that opens to the left. And that's not, we're not going to just write A, we're going to write it's the absolute value of A, because the negative part of A is making it flip to the left-hand side over the line x equals 0. And so what you need to be able to do is know that when you see this polar curve, you're getting a circle, and you need to be able to sketch that circle. Not by making a big table of values, but just by knowing. Okay, so for example, if I have r equals 3 cosine theta, I know I have a circle. (1.5) here. Whoop, sorry. That's going to look, whoop, like that. This is A. The diameter is A, not the radius.